I mentioned in the welcome video that AI has changed quite a bit since I first started teaching this course, and that makes it very interesting on the one hand, but on the other hand, it makes it very challenging um, because uh, technology changes very fast. Uh, when I was a student in computer science at UNC Chapel Hill, I often observed that the professors usually didn't teach us what the newest technology was. I think at the time it was something like ASP.NET. Why aren't we learning this new stuff? And instead, they tended to focus on these concepts, these abstract, conceptual theories, these ideas of algorithms and data structures. And I realized now that there was a wisdom to this because the technology does change very fast. But, so what are we supposed to do about that? One of my colleagues, and I was talking with him at a conference, he said, well, what I do is I just dedicate about 2 hours every day to just trying all of the new technology, everything that comes out. And I wondered if this was really the best way of going about this, because what I want to give you is not just, okay, here's what the latest thing is, because I think given the thousands of podcasts and all the other resources, you can kind of do that on your own. I see my role as rather trying to do the same thing that those computer science professors did. That is to focus on something that will still be true long after today's technology is obsolete. So rather than just every single shiny new object that comes along, I want to focus on what are the kind of universal conceptual truths that you can take with you and kind of have as guiding lights for many years to come. And so I started trying to put together what I thought those were. And so I began with this list. This is only a beginning list, a first attempt at what I feel are the truths about artificial intelligence. So, number one, AI is really just statistical prediction based on history. And so there's a lot of key terms in there. So statistical and everything that goes along that with that. So driven by probability and driven by error. And then also the fact that it's based on history means that we are taking what has happened in the past as our best guess to make predictions about what will happen in the future. So even something like ChatGPT, this is nothing more than generation of words based on statistical probabilities of how they have followed each other in the past. And I'll demonstrate in a later video how that is. So, whether we're working with, complicated models like random forests or something simple like linear regression, what we're still doing is just taking some kind of inputs, that is history, and then mapping them onto probabilities. So we take the history of the English language, and then we figure out what words tended to follow these groups of words, and then we just generate the most likely word. So that what that means is that the surface may change, but the logic of this doesn't. So what are the implications of the fact that where a lot of our work is going to be driven by statistical prediction based on history? Well, what this means is that AI is going to be best where you have judgments that are repetitive, where outcomes are observable and feedback exists because you have to train these models. So that means the opposite of that is what AI is not going to be good at. So where goals are ambiguous, where values conflict, or where feedback is delayed. So it's unlikely that you're going to see really great results from AI doing something that requires a great deal of judgment, such as strategy, ethics, and leadership. Okay, so that's truth number one. Truth number two, AI is only one part of a decision. So if you think about this, I should probably cite my source for this diagram here. I'll put it in D2L. But this anatomy of a decision, you start off with data, and then based on the data, you run it through a model, and the model comes up with a prediction. So let's say you're trying to determine house prices in a particular area. You take the historical data, then you put it in through some kind of model, maybe a, logistic regression or something like that, and then it gives you some kind of number. However, that doesn't happen in a vacuum. That number is then fed into the next phase of the decision, which is the judgment. And humans have to exercise their judgment on what to do with the AI output. And then finally, based on judgment, that then the judgment may or may not translate into any of a number of actions. So to say that AI is going to be taking over processes is a little bit misleading, because what it's doing is it's handling probably just the prediction side and possibly the data side. So data and prediction, but there's still an awful lot that goes on in the real world that really requires human judgment. And your effectiveness as an AI implementer is going to be the extent to which you can identify where the human comes in to this process. Okay, so truth number 3, data, and because data is, the basis of a lot of this, data is what we call a socio-technical artifact. So this is a fancy way. The socio-technical systems theory is an information systems theory that with a very long tradition. The basic idea here is that technology is really formed by social relationships, and that social relationships are changed by technology. So it's this, you have to think about both of those. So you have to think about, when some kind of system enters an organization, there are social sides to how it's used and how it's designed, but then there are also impacts on the organization to the technology. So technology doesn't exist in a vacuum. It's a socio-technical system. So data doesn't necessarily reflect reality. So data is a consciously chosen representation of a part of reality. And I once heard it said that data is the result of meters that we have chosen to set down. And so what that means is your organizational data is going to reflect the assumptions and whatever else, whatever version of reality your organization has adopted. So that means the data that you have available to train the algorithms is necessarily going to be a particular interpretation of reality. Now, so what that means is that, the best algorithm in the world is not going to be able to do anything with poor quality data, or data with too many assumptions, or data that doesn't really reflect the decision circumstances that you're facing. And this is something I've seen again and again. Training data. So when we look at machine learning, we'll look at the role of training data. Training data is often the main roadblock to implementing AI solutions. So what is the data like? Everybody has heard this expression. It's often like the only thing some people know about computer science: garbage in, garbage out. But it is the truth that the data is going to be fundamental to the way the AI works. Okay. Later on, when we talk about the impacts of AI on work, we're going to make this distinction between, well, there aren't jobs that are going to be taken over by AI, just certain tasks. But it necessarily happens down the road that you can't change tasks without changing work. So if you have now automated certain tasks that before took up 40% of your day, that means you now have more time to do something else. And so the question is, what do you do? So automation does change work, changes the nature of work, the structure of work, the way coordination happens, the way groups are formed. It has a big impact on the way an organization works. And so technology is going to change roles, incentives, relationships, identities, and coordination. So the implications here are that implementation failures are usually organizational and not technical. And that AI adoption is change management disguised as IT. I like that quote. AI adoption is change management disguised as IT. And that, of course, means that there's change in the organization that is something more than simply a new tool. Okay, truth number 5. And I probably should not have called these truths. I probably should have called them hypotheses, because these are something that I have come up out of my own head and have not necessarily given a big proof. So I will change these in draft two and call them hypotheses. Uh, Hypothesis number 5. Competitive advantage derives from complementarity, not the AI model. And so complementarity means that, when an organization adopts AI, there's two actors involved there. There's the organization and the AI. And if the AI doesn't necessarily enhance something that the company does or the organization does, then there's not really going to be any sustainable competitive advantage. Like I said, everybody, if you have access to a tool, you can assume your competitors do too. So what are you adding on top of that? So AI value is a function of data availability, process integration, talent, governance, and culture. So those kind of capabilities and routines are going to be enhanced by the AI. It's not going to create something that wasn't there before, or maybe it will. Uh, this is all very new. Um, and the truth is models degrade quickly. So you can build a predictive model, but as things change, as data changes, as the decision environment changes, that model could become useless fairly quickly. But organizational capabilities and routines don't. Okay. So, the implications of these truths are this explains why AI first rarely wins. When you start off with just, okay, we're going to build a whole business around AI, well, you're really better off building a business and then thinking about how AI can enhance those capabilities. Um, and um, and this kind of is a preview of the first case. So we kind of have to think about the resource-based view. That is, what resources, do you have, and how are those enhanced by the AI, rather than just the AI by itself. Okay, hypothesis number 6. AI systems are probabilistic, not deterministic. So this gets a little bit more of the first one, which is about statistics. But the implications of this are that they rarely provide repeatable results. So they're just probable predictions, and I should say probable, and which means that if you run the model again, you might get a different answer. And so consequently, there's a greater need for human monitoring of these systems. If you're working a calculator, this is an example of a deterministic system. If you put one problem in, it's always going to give you the same answer. But if you give one problem into an AI, it's not necessarily going to give you the same prediction that it gave you before. And consequently, overtrust is a bigger risk than undertrust. If you're in making key decisions, such as who to give mortgages to, then there needs to be some understanding and monitoring of how those decisions are made. And of course, monitoring and fallback systems are much better than raw performance. Investing a lot of time and effort into improving the speed or accuracy of a prediction is not going to give you the return that having a fallback system or a monitoring system is going to. Okay, so those are what I view as the enduring truths that I hope will outlast the course, and there may be some more that come along. But the idea here is I wanted to emphasize that it is impossible for one person to keep up with everything that comes out. Every day it's something new. And it could be that when I'm showing you, let's say, an image generation tool, that it's not as new as something that you came across. And that's just the way the technology moves. But if I am demonstrating something, the reason is because I'm trying to demonstrate something that's more fundamental and conceptual and permanent. So to kind of show a point rather than just the technology itself. You could see the technology as kind of like an incarnation of certain ideas. So it's about those ideas rather than the technology as itself.